Good afternoon, participants from Thailand, and also good morning to John and Emanuelle from UK. So I am Nathapong Arimit from KKU-iLT. I am also Associate Professor in Civil Engineering at Faculty of Engineering, Khon Kaen University. So it's my great pleasure to be the moderator today for today's webinar, and which is the experiences of the faculty-wide curriculum reform, the UCL Integrated Engineering Program. Have you ever felt that when you are teaching students some topics that requires prior knowledge and understanding, students sometimes act like they have no clue at all about what you're talking about? Or when students already complete learning multiple subjects with the passing grades, but cannot pull those concepts out to solve real problems. And you wonder, how should you deal with it, right? And we might have been overwhelmed by different teaching techniques and tools. However, there might be something else that we should consider too. So our speaker today, Emanuella Tilley, is Professor of Engineering Education and Director of the Integrated Engineering Program, IEP, in the Faculty of Engineering Science at University College London, or UCL, UK. Previously, she designed the curricula for the IEP projects and global challenges to introduce problems, experimental research, and inquiry-based learning to multidisciplinary first-year cohort engineering students at UCL. The Integrated Engineering Program is an award-winning and globally recognized teaching framework embedded in the learning experience of the undergraduate students across UCL engineering to better prepare them for tackling future global challenges. Professor Tilley has established an international profile in the area of leading curriculum design and development, as well as cultural change required to support and foster innovation in engineering education within the higher education. She is a principal fellow of the Higher Education Academy, vice president for the European Society of Engineering Education, and director of education at the UCL Centre for Engineering Education. Another speaker today is John E. Mitchell, is professor of Communication System Engineering in the UCL Department of Electronic and Electrical Engineering, and co-director of the UCL Centre for Engineering Education. So between 2012 and 16, he was the secondment to the UCL Engineering Science Faculty Office, where he led the introduction of the Integrated Engineering Program, IEP, a major revision of the curriculum across the engineering faculty. In 2018, he was part of the team was awarded the HEA Collaborative Award for the Teaching Excellence. He has published widely on curriculum development, active learning, and issue of diversity within engineering education. From 2015 to 22, he was Vice Dean Education of the UCL Faculty of Engineering Science. Professor Mitchell is a chartered engineer, fellow of the Institute of Engineering and Technology, senior member of the Institute of Electrical and Electronics Engineers, principal fellow of the Higher Education Academy, president of the Engineering Professors Council, vice president publication of the IEEE Education Society, and was until recently a member of the board of directors of the European Society of Engineering Education and editor-in-chief of the IEEE Transaction on Education. So at KKU-iLT, we are building a community of practice together and value the role of teacher in education. So I'm very certain that everyone who joined this webinar really cares about education, as the education transformation mission of the KKU is the transformation of both educators and also the learners. So even the title of today's webinar is about the engineering curriculum. I'm sure that it will surely be benefits for all of us who come from across disciplines. So please join me to welcome Tilley Emanuelle and John Mitchell, our speakers today. Thank you very much for being with us today.
Our pleasure. Thank you very much. And delighted to see so many colleagues here today. So as was mentioned, my name is John Mitchell. I will start off and say a little bit about why we developed this change. My colleague Emanuella will tell you a little bit about the details, and then perhaps together we can discuss some of the challenges of change, but also some of the opportunities that the sort of change comes up. So I should probably say a little bit about UCL for those that don't know. We're based very much in the centre of London, in the Bloomsbury district of London, just in the West End. We are a multi-faculty university, so engineering is one of the 11 faculties that ranges from life sciences, arts and humanities, Institute of Education. And the centre that we both represent here is a joint centre between the engineering faculty and the Institute of Education. We are a research-intensive university. Our research drives a great deal of what we do, and that pervades through many of our processes. That research is at the heart, which can both be a good and bad things for those that want to focus on teaching. We are one of the largest universities. We are now the largest campus university in the UK. The Open University is bigger, but UCL in total has around 50,000 students. Around 25,000 of those are undergraduates, and around 3,500 of those undergraduates are in the engineering faculty. About 2,500 postgraduate and about 1,000 PhD students. And as I say, that research intensive nature can be both a blessing and a curse. For example, we do have a pool of PGTAs that we can draw upon, and you'll find we draw. Emanuella can talk to this. We draw very heavily on our research students to engage with our undergraduates. So perhaps a little bit of the history and why we came to this position. The short story, there are various versions of the story as to how this came about, but I think there was growing disquiet in the faculty in certain quarters about wanting to do something different with our education, wanting to set ourselves apart from some of our key competitors, but also that not a great deal had changed in the way we taught for some time. And so we, as often happens, acquired a new dean who was very keen to see changes made. We had some new heads of department. We also had a new head of the university who talked quite candidly at how we were, a research powerhouse who was doing wonderfully in the research area, but that we perhaps weren't paying quite the same attention to our teaching and could do better. So there were a number of pressures, and also we were hearing from our students that they, our graduate statistics were good. They were getting good jobs, but I think we, not just us, but much of the industry was saying, you're producing technically good graduates, but actually their communication skills, their other skills are not all that we really want them to be. We're looking for graduates that can work right across the business and do different things in different parts of the business. We know we're getting technically competent and technically highly skilled graduates, but actually what's setting up, what industry we're saying that set the graduates apart, they were really after were those that they, could talk to technical teams, but could also talk to clients, could present and pitch ideas, and and could really drive elements of the business. And so there were a number of pressures into how we might change. And I think as part of it, you've probably seen a growing movement from, colleagues like Olin and Urbana-Champaign and other parts of the world where there was a drive to change how engineering was taught. And so in the early days of our thinking about this, we went really back to first principles to think about what it was that is really behind what we're trying to do of engineering and how we conceptualize engineering. And this was a phrase, it's sort of based off of one of the original definitions of engineering from Truslove, who the founder of the civil engineers. It's a bit of an adaptation, and my colleague Emanuella also adapted this and used it. But we talk about engineering being the art and practice of changing the physical world for the use and benefit of all. And this was quite important as a framing for what we wanted to do and how we wanted to change. And so we use this quite a lot now to think about what it is that we see as different in the framing of our education. And I'll come back to a little bit about what, before we move on, about what the changes might be. So maybe we pick up on some of the terms in here a little bit. So the first one is the idea that there is an element of art. And with that, with art comes the concept of creativity. And I think one of the things that we particularly noticed talking to our incoming students, but also talking to industry colleagues, was, you know, we don't play to the idea that engineering is a creative subject. It's about building things. It's about developing things that have never been. There is an artistry to it. There is a, you know, within technical constraints, it's not art in exactly the same sense as artists would recognize it, but it has a fundamental creativity. It is about invention. It is about development. It's about being able to bring to life something that had not existed before. And this is a brilliant young student who was on the engineering pathway in our liberal arts program, who early on in the development said to me, you know, I wish I'd known what engineering was. I just thought it was something about, you know, solving equations, that, you know, people who were good at maths went and did engineering. And, you know, while maths is a necessary skill within engineering in many parts, I think we're arguing it's not sufficient to be a good engineer. There's the creativity that runs alongside it is what we really want to see in engineering degrees. And again, I think these types of phrasing can be applied to many different disciplines. I think we also wanted to develop the concept of practice. I think we found that our degrees had become very theoretical in the main, and that we spent a lot of the first 2 years on what Dave Goldberg talks about of the math science death march of we must teach you a load of facts about stuff, a load of theory, before we can even allow you to do anything. And I think what that does, and particularly why I like this picture to illustrate it, you know, the sort of maker creative aspect of practical experimentation and developing something is something we do with our school groups all the time. But we don't really do it with our students to the same sort of degree. And we wanted something where students had an opportunity to really see that connection between theory and practice from very early on within their programs. But within that, I think there is a flip side to that coin, that we must recognize that engineering has is about the physical world. It's about addressing the physical world and addressing the problems of the physical world, and that it must be for the use and benefit of all. And I think what we really wanted to do with the program is really emphasize the societal impact that engineering has, and ensure that as we develop the technical skills, our students understand that they will have an impact on the world, for good or for bad. And that, you know, engineers have a great deal of responsibility and have not always acted in that responsible manner. And I think we must acknowledge that, and acknowledge that with our students, that, you know, many of the challenges that engineers are going to be absolutely critical in solving were actually created by engineers in the first place. And that if we'd engineered the world and our infrastructures and fundamental systems somewhat differently in the first place, we may not be facing the challenges we see today. And these are, you know, this is a fundamental responsibility of engineering. And one, and I'm sure Emanuella will talk about the design process we use, one that is fundamental to the design process with engineering from the very start, not something we consider later on. So they were some of the fundamental parts that we wanted. We also wanted to consider how we increase the diversity of our pool of students. And I mean diversity in every particular sense of the word. In the UK, generally, when engineering and diversity is mentioned, we talk about the poor gender balance that we have across the profession and across many of our taught courses. And while that is important, I think we often argue that that's a symptom of a much wider issue, particularly this focus on a narrow pool of mathematics and physics students that we bring into our courses. So we look to diversify the intake we took, but also I think in the way we frame many of our impacts that engineering has on the world. And so we were very keen to look at how we drew from a much broader circle of people and really emphasize the what engineering can do as a career and the types of career it brings out. So I think we find, you know, we find those that come from school have a very narrow view of what engineering is. And to be honest, that's much our fault. We emphasize certain things, you know. Mechanical engineering always has a motorsport. We always talk about motorsport and mechanical engineering, and we always talk about construction when we talk about civil engineering. We play in many cases to the stereotypes that are out there of the different disciplines. So that says a little bit about why, and so I think, before I hand over, just say that led us to a process of to reevaluate what our courses should be, how they should look like, how we should attract students to them, and what the framing of them was. And I think it's important to say before people get too scared, because I gave this presentation to many of my colleagues and they all got worried at about this point, that you're going to rip up the entire curriculum and do something completely different and new. Well, you could do, and I'm not going to stop anyone from doing it, and we worked with colleagues that are doing that. You've got to acknowledge, particularly, if you're a large university that's research intensive, there's a lot that will need to remain. And so I think what we often talk about the IEP being a framework that introduced a different emphasis within the program. Now, if you walked into 90%, 80% of the classrooms, you would see something that looked very much like what was going on before in many instances. You would see, they've evolved over the years, but not necessarily entirely because of the changing framework. But I think if you look at it from a student perspective, the students see something that is different, that feels different, because the theory isn't the front and center and the only thing they see. They see a change. And so there were a few things that were important to us to remember. And I think, there is always this tension, particularly when we did a lot of focus groups with industry, about, are we training students for industry or are we giving them a broader education? And that's always a tension between, as what we're actually required to do. And I think there is an element of both. We want, and I think the more enlightened industry tend to see this, that we want students, we are training students for the whole of their career, not that first job. We're not necessarily training them to have the skills just to go and make profit for the company day one, which is sometimes what industry is asking for. And I think, we've often said the marker of our success is not that our graduates get jobs, because they were getting jobs anyway, but where they are in 3 to 5 years' time. We expect our graduates to have accelerated, to be leading teams, to be higher up the elements of their industry than we perhaps would have expected before. And that that's our marker of success really with our graduates. We wanted to focus on motivation and agency within students. Again, I think one of the complaints about the theory is the lack of agency and the lack of motivation it provides in students. And so bringing in different elements, a project-based curriculum, really allows us to do that, but also to treat our students as professional engineers from the very first day, and to bring the expectations that we would have and some of the authentic practices that engineers adopt, and expect that of our students from very early on. And as I mentioned, this element of social, economic, environmental sustainability, our responsible innovation criteria, global responsibility, as we often talk about now, really being at the heart, and something that our students see from the very first day that they join us. Quite often we see that, but for accreditation reasons, every course has to have an element of this, but it can be very different depending on where you do it. I've seen courses where it's a third year module that's tucked away somewhere that tells you about these things, not linked to anything else, or not developed and not put into practice. We expect our students to be thinking about this in the design of their aspects right from the very beginning. And of course, I mentioned right from the beginning, our industry is telling us they want confident communicators, confident team workers, and it is beholden on us to support, as well as acknowledge that I think we've, many degrees have had group activities, teamwork in there. But I think one of the things that really struck us was there is a question of, but are we training our students to do well in those environments? We may be giving an opportunity to practice in those environments, but are we supporting them to do well? And that's something we must do, while of course maintaining the deep specialist knowledge that we are known for. So over the course of the first year of the development of this, well, first 9 months of the development of this program, we came to a set of conclusions about what this might look like. That it would be heavily focused on problem and project-based learning as a central strand to the program. It would have authentic activities and research-based, with group learning and group assessment elements far more than we had before. And we drew on engineering education research. We knew that was going to be important, and that we both wanted to do research but also understand the research. Engagement with industry, with the caveats I've placed, that you occasionally have to filter what industry wants to what you can deliver and what you should, and make sure you maintain those expectations, as well as connection with alumni. And perhaps the one that we found most challenging in the staff development, and particularly development of the teaching spaces. And I think I might return to this later on. If there's one area that I think we found the most challenging, was to develop our teaching spaces to be able to teach in this new way. You'll see contrasting between our two different backgrounds. Emanuella is in front of the portico that was built in 1826, and much of the core of Bloomsbury are buildings that are nearly well, that's nearly 200 years old. Many of them are 50, 100 years old that we're operating in, where we have really serious constraints on what we do. Whereas I'm sitting in front of, this is Poole Street on the Olympic Park, and this is Marshgate, our two new buildings which we've just opened, which is now our opportunity to think about the types of spaces that we teach in. But we've been doing the IEP for 10 years, and these are only just coming into operation. So that has certainly been a challenge. So hopefully that gives a little bit of a flavour of why we've done this. I'll hand over to Emanuella to tell you a little bit more about the detail of what that actually looks like.
Thanks, John. Yeah, if you just want to go to the next slide, that'd be great. So the integrated engineering program, we set out these aims, and hopefully in the next couple of slides I can touch on what this actually looks like. So interdisciplinarity was something that was at the top of everyone's interest. We are fundamentally siloed in terms of how we are structured with regards to governance and even where students sit within our faculty. So civil engineering, mechanical engineering, the 9 or 10 disciplines that we have, they're all departments, and they're very independent of each other. Our students come in and out of departments, and we don't really have a faculty presence. So this was our opportunity to break down some of those barriers because actually our research was already doing that. So we wanted to bring that into the education space. So certainly inclusive curriculum means how do we actually promote it in the way we teach, and what does that mean? So that was also an opportunity for us to look at that. Authenticity from the beginning was it is that theory and practice, allowing the students to develop more of their skills and put the practice more at the core of the student experience. But I do think that, and we've done a little bit of work around what authentic learning is, and the different dynamics and the different, I suppose, types of authentic learning, and how we don't, and John likes this phrase, we don't have puddles of this, we have streams of authentic learning, so that we introduce it in the first year, and the complexities that we expect the students to tackle kind of develop and progress as they get into their 4th year. So certainly there's a large emphasis on design, and that's a big premise in which we ask the students to practice and go through the project work or the problem-based learning work. And certainly professional practice was something that we don't just expect them to experience, but we do now teach it. And we allocate time in the curriculum to teach skills like critical thinking, and what are the underlying concepts of critical thinking, and the ways and the concepts, but also the techniques they can use. And then we ask them to put it into practice. So that we certainly allow the students to maintain their disciplinary strengths. They do understand more the strength of our research as well, because we bring that more into their curriculum. And it's completely embedded into the program in which they enter into. So our students still apply into a BEng or our Bachelor of Engineering degree. Some of them are Bachelor of Science, because we have computer science students that are also under the framework of the IEP, and then the masters, the integrated masters that we have as well. So it is not a separate program. Like we said, it's completely embedded, and often the students don't even recognize that it's there. We have to tell them how unique it really is. So if I go to the next slide, it shows you a bit of a structure. John, if you could maybe just touch through all of the points so that it comes up. So these are our departments in the vertical. Those are all the subject departments that we have that are impacted by this cross-faculty framework. And so in the first year, we have quite a lot of the most change, I guess you would say, and we focused quite a lot on the first and second year. So in the first year, we brought in problem-based learning and project-based learning from the beginning, from the first day, with our engineering challenges module. We also have alongside that our design and professional skills module. That's a credit module where we put it in to teach the skills and get the students to understand what those skills are. And then we also completely changed the way we do mathematics. So mathematics used to be taught by the mathematics department or faculty, and we've cut ties with that and brought it in-house so that it's more of a mathematical modeling and analysis class than it is a theory mathematics, calculus 101, linear algebra 101 sort of stuff. So it's very much applied, and only really at the back end of our 10 years have we now integrated scenario-based learning and project-based learning into our mathematics. And so that is quite unique for us too. But I believe that we've gotten there because we've always wanted to bring the context into our mathematics, understanding that mathematics is a tool and a language for our engineers to use, understanding that the equations represent systems, engineering systems and models, and what do those variables mean in real physical space or time or different concepts and variables. So that has only really come because our students are so used to that open nature of problem-based learning. So that has really come on inroads, particularly since COVID. And so one of the reasons why the next thing, scenarios, is green is because scenarios is our other buzzword or our label for problem-based learning. So we do challenge-based learning, as you would call it, and then scenario-based learning. And those are our labels for our project-based learning. And so it starts in the first year and then goes through to the end of the second year. And our scenarios are unique in such that they're 1 week projects. They're 1 week intensive projects where students don't go to their normal timetabled classes or lectures or labs. We cut out 1 week, and we've designed a project to be able to break down the barriers of the modularity of their learning. So if they're currently working in 4 classes, 4 different topics, then we try to build those projects based on what they're learning at that time. So there's an interaction between the project and the actual core content that's in their degree. And so as you can imagine, because we go across these departments, the scenarios are discipline-based. And so each department is doing their own scenario at the same time. So there are 8 projects at the exact same time. And so we have 6 of those, 2 for each term after the first term. And I'll show you in the next slide what it looks like. We also have 2 other things. So how to change the world, particularly in the red there, is our final, we call it a capstone project. It is the scenario that's 2 week intensive. It's the end of the second year before they go into that final year of the bachelor's, where they have that major complex ultimate project, capstone project for their degree. How to Change the World brings in the SDGs, it brings in community partners, and it brings in experts. So it allows the students to really actually take on a socially driven problem whereas before all their projects were technically driven problem or disciplinary based or research based problems that were related to engineering in some way. So we are really stretching them after 2 years of doing projects and really kind of integrating into their discipline and into the interdisciplinary space to come back and have a look at how engineers can tackle those socioeconomic problems associated with the SDGs, the UN SDGs. And so I would say it's hard to see, but the purple and green line right next to second year means that we have design and professional skills as a thread going into the second year, as well as the mathematics goes into the second year as well. In the third year, which we haven't really talked about, and not too much in this presentation either, but we've introduced a minor now. So our students that come into, let's say, civil engineering have an opportunity to broaden their degree and their experience at UCL with an opportunity to do a minor, much like the North American style, a major and minor, in an area that is going to complement their studies. So this, we're adding that opportunity for choice. It introduces them to our research that's much more interdisciplinary, and the students now break out of their silos and work with students from across the faculty, which is a really nice thing. So we introduce the minor in the second year, and they complete it in the third year with advanced modules. And now, because of this framework we have at the faculty, we have a lot more interdisciplinary projects in their capstone projects of their degree. And so that's simply because, you know, departments are working together, and now particularly some of the projects that were very focused in the discipline are now branching out, like mechanical engineering are working with electrical engineers and computer scientists quite a lot, because those type of disciplines are working in that interdisciplinary space authentically in the industry, so, and in research. So that's the structure, if you like. If you go to the next slide, it presents to you how we situate the project-based learning. So we would say this is our spine of projects. So the incoming student has the challenges, and then the 6 scenarios, and then how to change the world before they get to their third year project, which for us, we believe this is incredibly important, because they are in a different team each time. We are testing different skills depending on the level of complexity and what the content is. The context of every project is different every time, and it's real. Many of the disciplines like to introduce different industries that they're associated with. So for instance, for chemical engineering, they have petrochemical for one, they have food processing for another, they have oil and gas for another, they have all of these different types of industries, and it allows them to bring in their industrial partners earlier into the degree as well, which is really lovely. The challenges module is interdisciplinary. That's their first project. It's actually broken down into 2 projects. That's a full semester or full term project-based learning module, and we just want them to slowly get into the working way, or the learning atmosphere of working in teams, working on a project, understanding how design is going to be the way in which they go through their work. And as well, we put them in the second project in an interdisciplinary group. As you can see, this is not to scale. So the maths and their disciplinary content is actually 75% of their degree content. But what's important here is that we've given them opportunity through the project-based learning to integrate their learning. And you'll see at the bottom that design and professional skills is actually a skills-based learning module where we introduce those skills, as well as how contextually they are associated with the design process or that design practice. Next slide, please. So design has been center stage for us. That's one of the first thing I did when I first came into UCL. I was hired a lot because of my industrial background. I came from industry, worked in the built environment. I came with a background of mechanical engineering and civil engineering in my academic life, or in my studies and my research. And so I was able to bring in that authentic practice of interdisciplinarity, but the way in which we work as a team is to go through a design process. We work from the start of a project to the end of a project, understanding that there is a strategic way of designing, and that we wanted to bring that into the students' world. So that downstream step that design used to be is now very much fundamental at the upstream step, and we wanted to bring that into the students' learning. It's no longer the aesthetics at the back, it's the planning and the strategic way in which we meet user needs and requirements of our stakeholders. So now what we did, we want to make sure that the students realize that people are at the center of our work. And so that mediating principle of that relationship between the work that we do and how the people of the world or society are going to embrace it, is also something that we bring in. And this is all based on how we teach design. So for us, if you hit the last button, John, we want them to think strategically about their design and not reactively. So if you look at the next slide, it's the design cycle that we created as a faculty. So in many ways, you must all know that if you Google design processes, there will be so many cycles out there. And so it was important for us to understand a language that we could use, because we were now doing interdisciplinary projects. So when computer science students come in and work with mechanical engineering students, they won't have the same processes as part of their discipline. So what's the language that you're going to use so that the staff can relate to this and be able to teach it? When we did that conversation, there were three things that were really important to us. One, we needed to look like it's not a linear process, right? We all know that. So we wanted to make sure that it looked like it was a linear process. We also wanted to make sure that the students understood that it was an iterative process. So there are loops and loops within loops. The other thing as well is that for us, and this comes from my engineering background, where I really came in because of my industrial practice, was that I understand as an engineer, and I think researchers do too, that making judgments along the way, those decisions you make along the way, are the most important thing about being an engineer, and actually the really difficult thing to do. How do you make those decisions? What evidence do you use? What data do you have? When, we're often working without enough information. So we want the students to be able to realize that and still be able to have the confidence to make those decisions. So for us, this is a decision-based design cycle. So we put judgment and decide at the center of it, because much of the assessment is associated with how they came to their, decisions. And the other thing was, we want to make sure that all the problems came with a need. We wanted to make sure that the problem wasn't just a technical problem, that they understood the stakeholders that would be associated with that problem. The need is always coming first in some way, whether it's a rich need or it's just enough to give them a sense of what the project is about, depends on the project itself, but it's always there. That context is always there. Next slide, please. Then, so the scenarios, I think, are now really fundamental to what we do. Originally, everyone thought it was an add-on. Everyone thought that, oh, we're just going to pop in these new projects and there'll be nice, fancy projects and the students will all enjoy it. Actually now, the departments see it as fundamental to the students' learning, because what we know of project-based learning is that students develop their own knowledge. And if we believe in the constructivist way of learning, we believe that these are opportunities for students to create their own learning, to be co-creators of their learning. And so these disciplinary-based projects are really important for them to understand the core concepts of the discipline. And so these are two mechanical engineering based projects that are quite complex in how they have to make and build them, but they also take the weeks to design it in a CAD sense as well. So mechanical engineering have done a really clever way of using 1 week of the term and the scenarios to do the CAD based elements and the stakeholder requirements for it and understanding what the project and the need is, while the other is to build and make it and reflect on how it worked. These are also often associated with UK national-wide competitions, and so that our students have done very well in these competitions since, because of these projects that we're embedding, that application of their knowledge. Next slide, please. So for us, my last couple of slides are really to say that the application of and understanding that context is something that we have to introduce our students to from the very beginning. I tell the students in their induction, in their first week, that we understand that they are highly competent. They have a real keen interest in the principles of science, whether that's our sciences or our mathematics. Often our students come with that, but that, and we know that's their strength, but we are going to pull them out of their comfort zone and get them to think about science and mathematics and the principles around STEM learning that they have all come with an enthusiasm with, and also talk about those contextual elements of that. So understanding the risk of our work, the ethical implications of our work, the social implications, environmental and financial impacts. Now, how we introduce this to them in the first year is very different to how we introduce them to it's no longer an introduction in the fourth year. So even though with the IEP, we changed a lot of the first and second year, and perhaps not so much in the third and fourth year when it comes to their core discipline, what we're realizing now is that particularly when it comes to those solutions that they come up with and they work on in their later years, they're much more sustainability driven, and sustainability is now core to the work as opposed to an add-on, because we've kind of introduced these really contextual elements from the beginning. So when we ask them to think about, the impact of their work in a sustainability context, I think it's easier for our students to draw on that. Now, over the years, we've continuously had to think about how we teach these elements, because it's not easy. It's not easy to add, ethics in the first year and how we progress them. So it's a continuous process with the students kind of part of that to tell us the feedback, how they're receiving it. Do they understand it? Do they understand where it fits? And I believe it's a bit of a co-creation there about how we constantly try to improve. The next slide, please. And so just to say, our last project here with How to Change the World, it's so important to us. We see it as the capstone of the IEP because we are building up that ability to work in teams, work on authentic projects, for them to understand where their disciplinary knowledge can really support them in the work that they do. How to Change the World, we bring all of our students together in the second year, and each of the teams are made up of students from every department. So they're larger teams. This is an opportunity for them to work in a different dynamic. Usually the teams are about 4 or 5, or at least they have sub-teams of 4 or 4, not 5, but 3 or 4 is usually where they work in their teams before this. So working on a premise where they work on, clean water or sanitation or any of these that we've worked on before, in a context, in a location. There's often 2 locations that they can choose from, whether they want it to be a local UK-based context or an international context. And there's a community partner with every cohort that takes on a project. So we break them down into about 8 cohorts. And each cohort is then broken down into local or international. And each cohort takes on a topic. And so for these 2 weeks, as a team of 7 who have all done at least 7 or 8 projects already, each of these students working in different teams, we ask them to bring their disciplinary knowledge, to work as a team, to then consider how they then would propose a concept on how to tackle the project underneath one of these themes of the UN SDGs. So that's How to Change the World. We're now actually up to about 1,000 students for that each year, for that 2-week activity. And so at the end of that is quite a presentation of their work. It is quite a showcase of their work. It's a real opportunity for us to kind of congratulate them on all the work that they've done so far, but also for them to reflect on their experience, because that project work and what they thought of the project work particularly, or even the learning experience at UCL Engineering from the first day, has changed immensely in those 2 years. They've developed so many skills. They're ideas about what their learning is and how they're tackling it has changed in so radically from the first day to the second year. So it is an opportunity for us to kind of touch base with them, celebrate their work, and really see how they come together in many ways to represent their discipline, but to work in that interdisciplinary space. How to change the world is often the one thing that our students talk about, how it's the thing they talk about in their interviews for their internships. It's right before that second summer, so that's where they get quite a lot of employment experience too. So yeah, it's one that stands out with our students as a talking point. So that's it from me. John's going to talk a little bit more about the challenges and strategies of implementing the change.
Thank you. Although feel free to chip in also, because I think that we've sort of, between us, we've had dual roles in that I sort of started the process off, but actually what we've really come to realise, that I'll come back to, is there's both the initiation but also the maintaining, and both are actually very, very critical parts of how you keep, how you deliver a program. The final part, this is something we're talking about a lot more, because we often get asked to talk about what the IEP is, but more and more we're getting talked about, well, yes, but what were the issues? How did you come to do this? What were the difficult conversations and things like that? And so this is quite a candid view of some of the issues that came up and some of the challenges we met in trying to deliver what, as I hopefully you've seen, makes a fundamental difference to the way we teach, and has added some elements, but also rearranged some elements. Again, across 8 departments who were all teaching, we had it was about 800 students when we first started. As Manuel says, we've grown to nearly 1,000 now. So this is, some have likened it to trying to change 2 wheels on your car while you're still driving down the motorway. You've got everything going on around you, and you're trying to develop, make a major change. I think probably the biggest conversation that really comes up is, all these other things are great, but what gives? What are we going to lose by having to make these changes? What is it going to be? Because at the moment our curriculum is packed, and this is the thing we hear most. We've got all this good stuff that you absolutely must learn as an engineer, but I guess what people feared is, well, are you going to have to throw some of that away if what you really want to do is put all this other stuff that is being called for? And I think what we've discovered is that there are 2 aspects to this. One, actually, yes, you do need to look at your curriculum, and I think we should be doing this anyway. They are overfull. I did an exercise with many of my departments where I asked for them to identify the last thing that they'd taken out of the curriculum and what they've put in over the last 10 years. They could identify a very long list of all the new things that they'd added, all state-of-the-art stuff that they think our students demand. Could they identify what they'd taken out of the curriculum, what they'd decided not to teach anymore? I did it with electrical engineers, my own department, and the thermionic valve, they could say they got rid of. Someone thought they'd got rid of Smith charts, but someone else, yes, I know, I saw that you took that out, so I put it back in, and I teach it in my module now. These are the sort of conversations we have. So, there is a challenge to that. But I think what we have discovered is that my slides are now slightly in the wrong way. This should be the next slide. Particularly when you want to bring practical elements in. My slides have gone out of kilter. Never mind. That there are actually, I think the staff saw some of the practical elements as a bit of playtime. Oh, they're fun for the students. Yeah, the students will like them, but do they actually learn anything much out of doing them? And I think what we've discovered over the 10 years is departments have really found that actually they teach a lot. And interestingly, the students feel they learn a lot of deep technical knowledge from the practical, I think, and that was a bit of the talking point, that staff were worried about whether they learned technical knowledge in the practical. And so now actually they are a fundamental part of the teaching. They're not just nice projects to give the students something to enthuse on. They are being used to deliver knowledge. So I think what we argue now is, yes, you probably do need to think about your curriculum, but actually when you look at it, there's an awful lot of things where we don't always know what's in the curriculum. So one of the most interesting exercises I did with staff was to get the core teaching staff into a room and get them to think through what was in the curriculum. So I sort of got known for using these big post-it notes as a style. And so what we did with departments is to actually map out what their curriculum was of their first 2 years and try and think about what it was that were their fundamentals. And again, we had many interesting conversations about, why have you written this 3 times? It's like, well, it's in the syllabus of 3 different modules. So that's why it's written 3 times. Or, why, many people picking up post-it notes going, why are we still teaching this? Because I think actually this, generally, partly because the car is going down the motorway, we don't spend time looking at the parts of it so much. We may look at threads. I know my colleagues in materials, for example, often talk to each other. But do we often really pick apart and have a look at the full oversight of the curriculum? So I think there are opportunities there to rationalise the curriculum, create some space. There are some difficult decisions. I think we did have to make some difficult decisions about we can't teach everything. But actually, we found that the project-based activities, you can teach a lot. You can teach technical skills, you can expand the soft skills, you can do a lot at the same time. So I think that was one of the key learning parts. The other one we sometimes talk about is, there are a lot of opinions on what is in and out, what should be in and out of the curriculum, and a lot of viewpoints will be put forward. These were some of the ones that I heard repeatedly, and I'm sure any curriculum development process will hear it. Accreditation won't allow it. I'm sure you have an accrediting body that people sort of usually fear that they might not be accredited, and that, if we deviate from what we had before. I mean, actually, we found that the accrediting bodies were incredibly supportive of the idea of change. We had a very good relationship with them, and they were very supportive of us making change. I've talked about the no room in the curriculum. I was amazed to discover people had a view of what the regulations of the university said should be done, many of which actually weren't entirely true, but had always been done that way. I think people sometimes confuse what has always been done with what's actually allowed. And we spend a lot of time actually picking apart what we really were able to do within our curriculum. And certainly, I discovered things that I didn't, flexibilities that I'd assumed wouldn't be possible, that actually, the regulations wouldn't allow. There are questions over staff. And I think one of the things that, again, when I do these talks, often concerns people, one of the first questions I get is, well, how are you going to get everyone to teach in this new way? And I think our short answer to that is we didn't. And we acknowledge that there were some people, we had a core band of enthusiastic people who were very keen to make a change, who we harnessed, and a lot of people who wanted to teach the way they'd always taught. And we found a process whereby there was room for them within the curriculum. We weren't, if you were building a new university from the ground up and you could recruit the staff in the mold that you wanted them, yes, you can do something different. But we acknowledge that, our undergraduate programs across the faculties involve, well in excess of 500 staff, many of whom are, research focused, and that's what's got them to where they are in their career. They teach well enough, but teaching isn't something they they can afford to put huge amounts of time into. So that adaptation, I think, was important, and allowing and playing to the strengths of the staff. And not asking them to do something that they are uncomfortable for, because I honestly believe that a member of staff who isn't comfortable teaching in a problem-based learning style is probably worse than them giving lectures. I think we have to recognise that. I was told a lot we won't get the right space to do this, and yeah, they were probably right. So that's the one thing I would say: make sure the leadership and the resources you have to create an environment, because you do need different sorts of spaces. We ended up renting a lot of hotel ballrooms in central London to try and teach some of the group, to have open flat space to teach large group work. So our students sort of used to Art Deco features and mirror balls now in their teaching spaces, because we've been teaching in some of fancy London spaces to try and give the sort of spaces we need, and we're gradually catching up with that. But obviously, developing space takes time. I've talked to those. So we often talk about the staff being conservative and staff not always necessarily, you know, how you get all staff on board to make change. I think we also need to recognise that students are conservative too. Students come with a very solid idea of what it is that how they're going to be taught, how they're going to learn, and you know, they can be surprised by changes in the curriculum. These are quotes from about 5 weeks in, when we had a student staff consultative committee of, you know, student bang on there. I came to do science and hard sums. I did not come to write reports and work in teams. That's not what engineering is. You know, they have a, you know, we generally find there's 3 groups of the students. There's those that are, you know, go along with it. There's those that absolutely get it and are hugely enthusiastic. And there's always those that this isn't what I thought it was going to be. Generally, they come round, particularly in their second year when they start applying for internships and they go for interviews. As Emanuella said, I often share an experience where how to change the world is often what they talk about. And it was one of these students who was banging on the desk in how to change the world, going, why are you making us work in teams and thinking about working in developing countries? This is, you know, I just want to be programming stuff. This is stupid. And I met them after the summer when they'd come back from an internship interview. And I said, you know, I wrote How to Change the World as one of the courses on my CV. And when I went into the interview, that's, you know, the first thing they asked about, you know, what on earth is this How to Change the World? And I told them it was working in interdisciplinary teams around the UN sustainability goals, and we had, you know, really difficult problems with an industrial partner. And you know, I spent 2/3 of the interview talking about this. You know, maybe there was something in it after all. And you know, that's the best validation we can get. You know, and they do come around to this. And we do see that. We see that the students really see these elements as you know, really some of the critical parts of their learning and of their journey. And these are things that they talk about and that they still reflect on. So these are quotes from graduate students that we've been collecting over the last few years in our longitudinal studies. And I think what we've now come to appreciate is we do have to recognise this jump that we make of students, and I think in our early years we could probably be accused of not having supported this shift in students as well as we could have done. And this is something we've put quite a lot of work into, as to how we both explain why this is different and why it's beneficial to students as they come into the programme, and that's really important. And yeah, they give us very positive feedback now they're in employment, and that how this is, you know, even some of the simple things, particularly the communication skills, the communications aspect of it is something they often reflect on. And a lot of it, I think, underpins this idea that they have this appreciation of professionalism and conduct and authentic activities right from the very beginning. So just a few sort of final observations of things that you might want to think about. I always thought, you know, change was a linear process, that it was hard. Actually, I've come to think, actually, the hard bit is getting change going. And so one of the things we were often told was, we'll do this change, but this is going to stick. Don't come back and try and get us to change anything else now. And you know, Emanuella is now dealing with this and finding the departments are very reticent to change things again. You know, they're really wedded into these things that they may have argued against to begin. And it's now very hard to, you know, we can make iterative changes to some degree, but it really has become embedded, which is both great, but also, you know, does present challenges. We like this model, it fits us, but we have to be clear, it is a model that was fitted our context, fitted our constraints, fitted the problems we had and what we could do. And so while we advocate this as a model that we like, we do very clearly say to people, you wouldn't want to do it like this, exactly. You know, draw inspiration from it and take things, and particularly use your own precedent. And this is something I hadn't quite picked up on, and Emanuella really first alerted me to. We've drawn a lot of what we do from things that were already here. And that gave us a real advantage with the staff of being able to show them and demonstrate what was going on. It was never done at the scale we were proposing doing it at, but there was some precedent. There were things that people could go and see in other parts of the university that just gave them confidence it was possible. And I'd take members of staff to see project-based work elsewhere, and you could tell the shift, that the conversations you had beforehand were very procedural, were very much about, you know, the logistics of how this could work. After spending an afternoon in the classroom with the students, the conversation was very much more how wonderful this is and how, you know, we could do this and we could do that, and it was a much more creative. It shifted the dynamic of the conversation. So being able to actually experience things is very important. So if you've got things that you want to build off, that's great. If you can't pilot them, get some way of getting the staff having experience, because that really eventually all leads to a culture change. And you know, the IEP, I'd originally envisaged that this was a change process. We'd have this team that would make a change, and it would just happen and stay. And I hadn't quite appreciated how much work is, you know, I think as much work, if not more, of now maintaining it and continue to develop. And you know, and Emanuella's team of the IEP is now seen as a supporter and champion for the changes that departments want to make and how they can continue to deliver. It's not universal. We have some departments much more engaged than others, and others are trying to go their own way, and we can support that as well. I think it's but the framework was a chance to make that step change, and now departments are taking ownership, and we're helping them develop that further. And with that, there is actually a lot of function. I mean, there's all sorts of things that were needed to be done to be able to support these changes. And you know, I think as Emanuella said when we first started, and I alluded to it, I mean, we're a big university, and our departments are really the centre of the universe in many cases. The faculty has been growing a presence, and so we don't have many of the procedures necessarily to keep the departments together, and we had to build that. We had to build that to keep it developing, and operate a faculty, and the collaboration, particularly in teaching, doesn't naturally occur. It's not naturally supported in the environment we have in the university. Our systems just, you know, I like to put everything in a box, and that makes it difficult. We did have one advantage. In theory, our cash flows with the students. So if one department teaches some other department students, the cash flows with it. So, you know, I'm often told, you know, changing curriculum is like herding cats. I've got 6 cats. I know how to herd cats. You just need food. And the same is true of departments. If you want departments to go in a certain way, money is a very good driver to bring an attention to what's going on. So, you know, I think that those sorts of things are key. The processes that underlie it, that encourage the sorts of behaviors that you want to happen, that encourage collaboration, they are actually quite important to build, and can be quite difficult to ensure the success of any programs. So I hope that's given some ideas, some thoughts, and I'll stop sharing, and we'll be happy to take questions.
Thank you so much, John and Emanuella. It's very wonderful topics, and it was a great work that you have been done. I think we have some questions from the audience. The first one is, could you please explain more on the group assessment and how you do it? Is it reliable, accurate way to assess student competency?
So I'll start there. So one of the things, I mean, it is debated about group work in isolation, what you're actually assessing. And there are ways of trying to understand and being clear about what that is. First of all, we should say that when you think of assessment, one piece of assessment sits within a strategy for assessment, and that strategy is within a module, and then also within the year of that program and then the program as a whole. So for us, group work isn't always assessing the core knowledge. It is in some cases, but in others, there are also individual assessments that help with that. So often our group work is assessed in a very dynamic way. So for instance, prototypes and demonstrations of their work is something that we would assess, and making sure that all students understand how the prototype and the testing works, showing how and understanding how the students kind of work as a team to be able to pull off that demonstration is something that we would say to students. Additionally, with presentations, we would expect all students to present or at least take sections of the presentation so that there is clearly, you can see that the group has some knowledge on that. Often we have strategies to say, you know, you give us your slides and actually we pick who's actually going to present each slide. So there are ways of saying, you know, in different points of their learning in groups, how we can trigger whether or not we are assessing, you know, the individual knowledge or okay with the group understanding. Sometimes in group reports, we get the students to kind of acknowledge where they've contributed, so that can be important. We do a lot of this, particularly in the first year, so that they understand that we want to understand who's contributing and where. We don't necessarily do it so stringently in all of the group work assessments, but because we do so many, we can actually understand if there are individual assessments that are alongside it, is that enough that demonstrates their core learning, whether that be skill learning or technical learning, and what does the group learning actually want to be assessing? So I think that probably more of a conversation that you have to have, because no one assessment sits on its own. And when it comes to projects, there's usually at least two pieces of assessment, and one of them is often individual. And that individual contribution is higher in the early years than it is in the later years, because in the early years, we really do want the students to believe that their individual contribution is something that we want to see. In the last years, because they've done so much teamwork and we expect them to kind of take full responsibility of that teamwork, perhaps there's less of that individual contribution. The other thing that we do is we do a lot of peer assessment, or we mandate actually peer assessment in all the group work. So the peer assessment isn't the model where students look at each other's work and peer assess it, but it's the contribution to the group, if you like. So we often do this more than just at the end of the project. Sometimes we do it in the middle of the project, depending on how long the project is, just in a formative way to understand the dynamics of the team, who's contributing, who's not contributing, so that we can get a sense as facilitators of that learning to kind of understand what's going on within the team. So that if at the end of the team, someone says, I did 80% of the work, well, at least you've got some touch points to say, well, does everybody else in the group believe that their contribution is the only contribution, or there are other things? So that contribution assessment is criteria based. And sometimes we set that criteria like a rubric, and sometimes we get the students to set that criteria based on the team contract that they set up. So that dynamic about when we teach teamwork, we talk about the responsibility to the team, how teams work, you know, how successful teams work, how they distribute the working of all the deliverables and the strategies that they do to meet their deliverables. And so they kind of formulate the rubric themselves on how to peer assess each other. So there are different ways of doing that as well. But in each group work element, there is that. Yeah. John, did you want to add anything?
I think the only thing to add, I mean, this is a tension with problem-based learning to some extent, in that while we say it will teach technical knowledge, it's very hard to prescribe exactly what technical knowledge. Because as soon as you say, I want the students to exactly learn this bit of technical knowledge, this bit of technical knowledge, this bit of technical knowledge, you end up making it a very constrained problem. And so particularly in latter years, you want the problem to be open. You want different types of solutions. You want students to be able to explore different technologies to deliver their solutions. So I think the model where we have these sort of cross-cutting elements of the projects means that actually the core technical knowledge, as Emanuella says, is tested elsewhere. And we are recognizing and valuing technical knowledge in the project, but not to the quite specific degree of being able to say, well, everyone knows that thing coming out of the project. And I think that's just something you sort of have to accept of the project work, that actually you are evaluating a technical contribution, but it's not necessarily a great tool to be able to deliver exact technical outcomes. And I just see the question here about whether it takes more time. I think, as I say, I think there has been some rationalization of the overall curriculum. But I don't think our departments are coming. I don't think our departments have ever really come back and said, actually, we've had to cut back, technical curriculum so far. And certainly the evidence is not. We're not seeing that, the end point that our students reach within 3 or 4 years technically is any different now that there is this thread of problem-based learning. So I think there was some rationalization, but I think the core is still there, and I don't think it has. I mean, and again, we use the problem-based learning or the project-based learning really to consolidate the learning of the lectures. So this thread that Emanuella described of where there's lectures and then a project, they sort of work in harmony to some degree on that. And so actually they are reinforcing, but also developing some ideas within those projects.
Yeah. So just to be really clear, our design and professional skills module that we put in, that's actually where the scenarios sit. So when we do that skills-based learning, when we teach them team working, critical thinking, risk, professional practice, ethics, all of those things in the first and second year, the assessment is actually the project-based learning. So even though we're calling on the knowledge from the other core modules that they're in the degree already, because they're not actually part of those modules, they already have exams on those modules like nanotechnology or distillation processes or, civil structures. The project is in the skills-based module, so we can actually assess them on their delivery of the design, while also a part of the criteria will be their technical understanding, but it's a smaller part of that because it's assessed elsewhere. So we can focus on the skills and the design based and the practicalities of their learning.
So through your presentation, I mean, actually I had several questions beforehand because kind of reformation is kind of quite a tough task, right? So John also mentioned that, okay, many difficulties or many kind of denial from the faculties to be changing, right? So I wonder, I mean, whether how this reform begins. I mean, where it come from? I mean, it's from the administrator forcing down, or it is from the faculties, some of the faculties itself, and then how it gets started?
Yeah, I think it was a bit of both, and I think it needs to be, in that I don't think any reform without the support of the leadership is going to be successful. I think that is a critical element for it. That you have someone, I guess it helps to be that they have a clear desire to see change and some vision of what that change might produce. Perhaps without a clear, without necessarily mandating details. I think where we struck a useful middle ground was we had a dean who had a clear vision of wanting change and some ideas about what that change might look like, but we were able to put in place a process whereby actually those that bought into that vision and were already enthusiastic and were looking for change within departments were able to shape what that change actually looks like. And so it wasn't that there was a blueprint of, well, you must do this, that came down from on high, and they were, people were forced to follow that. They were forced to change, but given quite a lot of latitude within that change about what that meant for their departments and there were some clear principles within it, and I think we stuck to setting principles that the new curriculum must have these sorts of features, must deliver these sorts of things, and there's some elements that we put in place that to allow those to come. But I think department, there was that balance with departments being able to take ownership, the enthusiastic and committed staff within departments being able to shape that. And it ended up, I think at one point I had 8 versions of the same presentation, there was a version of it for each department, because it talked very much to the things that they were concerned about and how they were reacting to things. And so it takes a lot to remember that you've got 8 slightly different versions of things going on. But there were subtleties between the departments, because they had different red lines, they had different things that concerned them, different, he talked to chemical engineering, sort of HAZOPs and safety must be threaded all the way through. So that was all over the slides. Whereas, computer science, that really didn't focus in the, so you had these sort of emphases I think the nice thing about the framework we ended up with was it allowed that to be there, that they could emphasize different things that were appropriate to their disciplines.
I think the other thing that you need is, see, we had the dean that said he had a vision, but then he made a post or a role, depending on, and that was John. So someone that kind of stood up and said, yes, I want to take a chance at this. If the dean is going to give some time to this and some funding, clearly John being bought out from a department and wanting to lead this as I think at that time, a senior lecturer, really kind of knowing that they've done a little bit in the classroom already. So he's got some experience of it. He's got some enthusiasm for it. He knows that he can pull the grassroots people that are already doing great things in their classroom. And also, if you gave them the opportunity, could really do more beyond their classroom and influence, then, you need that as well. So then the other part of that is, once he realized that this change was going to happen, he put in 3 roles, and those roles were myself. So I was hired, someone with an industrial background, because they wanted that authentic project. They had someone from mathematics and someone from the skills based. And so we all had very different backgrounds, but those roles were there for 2 years. I was actually only contracted for 2 years because that was the work that we wanted to do to implement the change. And so my whole first 2 years was, I was expected to be done after that, to create the curriculum and give it over to the departments. And I think so much happens in 2 years. You're given that opportunity, communities come together, the department sees the benefit of these only 3 people that are influencing 10 departments, what we meant to them, the helping them kind of create change and really leaning on us to do that. So we stayed, and we constantly are, like the Centre for Engineering Education has come out of that work, really, just kind of constantly the department saying, this is such a good resource. We could never actually do this in our departments. We can't hire a non-engineer, right? In the 3rd post, it was someone that was a technical communicator, a science communicator, and so had more of a social science background, and we needed that to teach some of the skills. So having that diversity is not often something the departments can do because of the constraints to produce research or produce teaching and engineering. So those, I think, for the change to happen, those were the small changes that were needed to be happening. And I say small relatively, because when we think about the impact on the number of students and departments, a secondment from someone that I was already there to lead it, and then 3 roles that were up junior. We were only lecturers. We were only hired at a low level, right? So, and expected to come for 2 years. So it was the seed that was necessary to lead the change.
Thank you.
And all three are still here 10 years, having just celebrated 10 years, and 2 are professors. So.
Yeah, exactly. Yeah.
Any questions from the floor?
Yes, please.
Please.
Hi, John and Emanuella. Can you hear me?
Yes.
Yes.
Okay. I was wondering about the supervision. when you assign the project-based learning or even the capstone design project to the students in each group, how can you manage the supervisors into each group when they to make sure that they are not getting to the wrong path during the way?
There's not a wrong path always. I mean, that's part of the you know, actually failure and going down those blind alleys is part of the joy of it. I mean, what we often do with the scenario weeks, because they're quite intense, so we tend to try and have a member of staff for 20, ideally 20 students, if not 25. So actually the ratios are quite high, because we often, you know, we have classes of up to 200, 250 we've had recently. So the student staff ratio is quite high. Some are PGTAs. But what we often build into the projects is, rather than really sort of intense supervision, is, you know, a lot of staff have sort of developed models where there's significant checkpoints through the week. So, and actually, you know, Emanuella brought a lot of this in from a consulting background of design reviews, and effectively we will have checkpoints where we can advise and question. You know.
Oh yeah, so so in terms of supervision, when it comes to first year and second year, they really need that hands-on every time they're in the workshop, because it's not a directed lab and they get instructions, you know, for the next 3 hours, this is what you should be doing. But if you're behind, then you've got to finish up on that and that, right? But it's not like do this, then this, then this. So it's literally like, what's the next step and how do you work together? So we have those meetings, we have those checkpoints, and the PGTAs, which are our PhD students, are a team that we train quite heavily, right? We bring them together quite a lot, and there's usually that module lead. So the module lead relies on them to be the touch point to the students. And then, you know, anything the academic lead kind of walks around the room in those sessions. So there are community, like we call them teams of teachers, really. So we've got the PhD students, which are the first contact point for a lot of students, and then we get the validation of the academic lead. And even those academic lead for all of those modules, because we have so many students on the projects, there's somewhere between 15 to 20 of them, because we have 1,000 students right across all the departments. So we bring them together to kind of have a practice, if you like. So a practice as in, you know, in the second week, we will make sure we sit down with them and have a meeting, and we will ask them these 3 questions. In the 6th week, we will do another checkpoint. And these design review meetings, as we call them, are formal enough meetings, meaning in this week, the academic's going to come around and this is where we expect you to be. These are the 3 things we're going to talk about, so that everybody, regardless of the project, has those checkpoints. And then every week we've got the PhD students making sure that the students are there and they know what they're, you know, at least they're not falling too far behind or really kind of being disruptive, you know, really breaking down. The assessment comes into a big part of that. So really getting the students to make sure they know what they're meant to be doing and how they're going to be assessed. So the rubrics, particularly around the project, you know, the technical report that they're going to provide at the end of it, or the demonstration that they're going to do, that's a really big harmonization process. So all the teachers kind of develop that. There's usually one module lead. We've got one member of staff that kind of leads all of it. So it's their responsibility to make sure that all of the feedback is in and they hold those conversations. But particularly around the assessment and what we're assessing, that's a community of teachers that pull that together. And then we've got those levels when it comes to the student supervision. That's really active.
Okay.
Yeah.
Thank you very much.
Yeah, it's a little bit different than the 3rd-year projects, where it's like a supervisor. That's almost like a PhD or a master's dissertation, where they come to the supervisor and usually they're doing research that's associated with their supervisor's research, and therefore that's a lot more difficult to kind of harmonize. But even that, I think because of the IEP, those 3rd-year and 4th-year projects, which are a lot more designed like that in terms of the relationship between the supervisor and the student, we've also kind of helped them reform that, so that all supervisors understand the assessment and they know, and they have checkpoints too, so that they know that they're kind of leading the students to the same end point and the expectation of what the students delivered. I believe that the departments are doing that a lot better now because of the systematic approach. it's influenced their third and fourth year, no doubt. Yeah.
I mean, and one thing, and I've just put a paper in the chat there, one thing we often see with staff, certainly new staff that are engaging in this, tend to try and be a bit over-structured in what they do. And actually, as staff get more experienced, you see that they allow more freedom for the students, keeping these well-defined points where they check. And I don't know whether escape rooms are it's a bit like being in an escape room with the students, that you're keeping an eye on them, and every so often if you think they're not doing so well, or you'll throw them a hint and have you thought about this, or you're just sort of trying to direct them along towards the final solution. It's that sort of process.
So maybe I think maybe we already spent almost 1.5 hours, and we have very thankful to John and Emanuelle for a wonderful, inspiring actually, because when I listen to you, I think we are all facing the same problem. I used to think that, okay, it's very difficult for us to make any change. But even at UCL, you mentioned almost the same problems that we have, right? And it's very inspiring for me that you push it through. And then now you see the fruitful results that you have. So we're trying to, learn from your experience, and maybe we can do something here, and maybe we can share something in the future, right? So thank you very much, John, and thank you very much, Emanuella, for spending time with us today. Thank you very much.
Pleasure. I hope we can continue to work with you. As we say, the centre is very keen to support others who are looking to do similar. So I hope we have a chance to work with you again.
Yeah, we'll keep in touch. Thank you. Bye-bye. Have a good day.